Look at another problem looking at Bezout's coefficients, and we'll start with noting that to find that, we're going to find that the GCD of 428 and 212 is equal to some value, which we'll identify, and then we're going to find that in terms of a Z-linear combination of 212 and 428. And so we'll see what that looks like in a second. But first we find the GCD by using our tried and true method that 428 is equal to some multiple of 212. And in fact, we can fit two of them in there. That becomes 424. And we have 4 left over. And then we'll go ahead and make use of 212. We'll say 212 can be written as some product of 4. In fact, we can fit 53 4s in there, and in fact, we have 0 left over. And so the GCD of these is 4. We always go back up that 1, and that's where we get the 4. So GCD of 428 and 212 is equal to 4. But now we want to write, and we know that we know that because that's the GCD of those two values, we know that we can write that out as some combination of 428, some multiple of 428, and plus some multiple of 212. Okay, and we know that there could be more than one value for that, but one way that we can find that value is by reversing all of this. So this tells us that this is 4 is also equal to, I can move this over to the other side, 428 minus 2 times 212, right? And so I can go ahead and say 4, and that's it for this particular example. 4 is equal to 1 times 428 minus 2 times 212. That one was pretty easy. So there's our S and T in this space, and you can do a quick check. These values, if you had multiplied it out, that's 428. We found it the first way around, minus 424, which is 4. Okay, so we can check that did work. And these guys right here, those are Bezout's coefficients. And that gave us a nice way to find them. Okay, next problem. Here we see that we've said for each pair of numbers, A and B, use them to find the modular inverse of each given value x mod m. Okay. So these are A and B, and so we want to find the modular inverse of 314, in this case, mod 375. And what we'll see is that in these situations, so we can only do this. So the A and the B are always those same values, right? So 314 and 375. So we can't find a modular inverse of 314 mod 375 unless the GCD of those values is 1. And so we'll check 375 is equal to, so to find the GCD of 314 and 375, that is 1 times 314 plus 61. 314 is, how many 61s can we fit in there? Can fit in 5, would be 305. So 5 times 61 plus 9. And 61 is equal to how many 9s? Something times 9. 6 times 9 plus 7. And 9 is equal to 1 times 7 plus 2. 7 is equal to 3 times 2 plus 1. That's going to be where we end off because 2 is equal to 2 times 1 plus 0. And so we know that then this becomes the GCD. GCD, because of that, of 375 and 314 is 1. Okay, so all well and good. But now what we've been asked to do is actually find the modular inverse of that. And the way that we're going to do that is first find Bezout's coefficients. Find a way to write all of this in terms of, to write 1 such that it's a combination of something times 375 plus something times 314. Okay, so how do we do that? Well, we remember that we can use these pieces up here. And so we know that from this here, we can say that actually, one down from this line here, we know that 1 is equal to 7 minus 3 times 2. It's just another way I'm going to move this value to the other side. I'm going to start from that 1. And then I see that I've got this 2. I've got a 2 here too. So I can think of 2 as, in fact, so I have 7 minus 3 times 2, but 2 I can write as 9 minus 1 times 7. And now I can move things around a little bit. I've got 1 7 plus 3 7, so I've got 4 times 7 minus 3 times 9, I think is what I end up with there. And I can go ahead and keep moving that around. I've got another way to write, if I look over here, I've got another way to write 7, and so I can extend it further. So 4 times 7 I can write as 4 times 61 minus 6 times 9, minus 3 times 9, which I can also write as, I'll just go to the next line, which I can say is the same as 4 times 61, so that'd be minus 24 and minus 3, minus 27 times 9. Okay, and I've got another way, here we go, to write 9. I can write 9, so I'm going to leave the 4 times 61. I'm going to say minus 27 times, instead of 9, I'm going to write 9 as 314 minus 5 times 61 from that last line that I pointed my green arrow to. And then I can move that around, so that's 4 61s and minus 27 times minus 5, so that would be 135 61s, 139. I've got 139 times 61 minus 27 times 314. Okay, woof. What now? I have to go one further because I actually haven't used every line. Once I've used this one up, then I know I should have found my answer. And so that's going to give me an alternate view of 61. So I can say, instead of 139 times 61, I can represent 61 as 375 minus 1 times 314. Okay, right from this line at the very top. And I got to keep that minus 27 times 314 kicking about, and then I can spread it out a bit. 139 times 375, and then here I have, minus minus 1 times 139. So I have 130, minus 139 and minus 27. So that's minus 166. Minus 166 times 314. Okay, so all of that together just gives us one important thing. It gives us that all of this is equal to 1. Okay, so what we see is we've got, I'm actually going to shrink things down so that we can kind of take a look at all of this in conjunction. I'm going to move this over. I'm going to make this a little bit smaller just so I can have a little bit more space. Okay, so all of this says, so we've got all this information, and what we see is, so we know that 1 is equal to 139 times 375 plus, minus, importantly, minus 166 times 314. Okay, and so what we want to know is what is the modular inverse of 314 mod 375. But if I look at this value, I can take both sides of this equation and I can say, well, actually 1 then on the left-hand side is equivalent to this whole thing mod 375, right? So 139 times 375 minus 166 times 314, all of this mod 375, right? But what is that equivalent to? 375 is in there. This whole thing is 0 on the left-hand side. So this is equivalent to minus 166 times 314 mod 375. Okay, so that doesn't look beautiful. It's not the answer that we want, but it's close because I want, essentially what I'm trying to find is the thing such that if I multiply it by 314, I get 1. So this is the answer that we want. The only reason that I say that it's not quite 166 is I need it to be a number between 0 and 374. So how do I get that? I just need to move it into that right range between 0 and 375. And we know under the modulus operator, minus 166 is the same as minus 166 plus 375. So I can just move it into the right space by adding. And if I add 375 to minus 166, I get 209. And so the answer that we're looking for is right in front of us. So we want 209. And I really am good at taking up a lot of space when I'm writing here. I'll try to make it smaller so that we can see it all. So there we have it. And so in the end, so 209 is the modular inverse of 314 in Z375Z. Okay, and that is the answer to that first question. There you have it.